Hi, and welcome to Algebra 1, Unit 3, Section 6, Compound Inequalities. Two distinct inequalities are joined by the word and or the word or. So let's have a look at an and inequality. Let's say you have x is greater than 1 and x is less than or equal to 2. Now, graphically, they look like this. You have an open circle over the 1, and we want the arrow to go to the right. If we graphed the x as less than or equal to 2, it would be a filled in circle, and the arrow would end up going to the left. So look how they meet with each other. They basically overlap, and it's the actual solution to the problem is where they overlap. On the other hand, if you have an or inequality, they do not overlap. So let's say that you had x is less than or equal to negative 3 or x is greater than 2. Now graphically, we have a negative 3 with a closed-in circle, and because we want the numbers less than negative 3, we want the arrow to go to the left. Now if we go over here to 2, this time we want an open circle and the arrow needs to go right because we want all the numbers that are larger than 2. Now the interesting thing about the and, the one up top here, is that we can actually combine these two inequalities up here, and we can make it, if we flip this inequality around, then we'll have 1 is less than x. And if we join this one here, this little one here, the x, and we kind of only put it once, we can have less than or equal to 2. So we can actually combine an and inequality so that there's two inequalities in one. The next thing I'd like to have a look at is solving an and inequality. So remember that an and inequality has two inequalities in one. So what I'd like to do is I'd like to draw a little line here, and I'm going to split this into two different inequalities. It makes it really easy to solve. So on the left I have negative 8 is less than m minus 5. For the right inequality, I'm going to use the m minus 5 again, and this time use less than 10. Now, as you can see, we're going to solve these separately, but then we're going to put them back together again. So let's add 5 to both sides of this inequality. We'll get negative 3 is less than m. On the right-hand inequality, I'm going to add 5 to both sides. And so we're going to end up with m is less than 15. And so now I'm going to put it back together again, just like Humpty. I'm going to put Humpty back together again, and this inequality back together again. So I'm going to write the m once, and on the right hand side I'm going to write less than 15, and over here I'm going to put the negative 3 and then a less than sign. So here is our solution. Negative 3 is less than m, which is less than 15. So again, remember the and inequalities are the ones that overlap. So let's put an open circle over negative 3 and 15, and it's going to be all the numbers in between that are our solutions. For our next example, I'm going to do this little or inequalities, and we're going to solve those, just solve them as if they were completely separate. So for the first thing I'm going to do is I'm going to subtract 3 from both sides, so we end up with 4c is less than negative 8, and then we're going to divide both sides by 4, and we'll have our solution. C is less than negative 2. That was pretty simple, wasn't it? For the next example, we've got, next part of the example, negative 2c plus 7 is less than or equal to 1. So I'm going to subtract 7 from both sides of this inequality, and I get negative 2c is less than or equal to negative 6. And then I'm going to divide both sides by negative 2. So we'll get c. On the right-hand side, we'll get 3, but remember, whenever you multiply or divide by a negative number, you need to switch the sign out. So this becomes c is greater than or equal to 3. So let's graph this now. We have a negative 2, and we want the numbers that are to the left of negative 2. Remember, open circle. And for 3, we want a filled-in circle, in other words, closed. and because we can include 3 in our solution, and then we want all the numbers to the right. For the last part, this is my favourite part. I love interval notation. It takes so much work out of everything. They use it a lot in calculus, so it's very useful. If I was going to write the interval between 3 and 5, but not including 3 and 5, in the basic inequality notation, I would write 3 is less than, our number that we're looking at is less than 5. So you see how much less work that is? And on a graph, it would basically be the numbers between 3 and 5. So when you say between, you don't include the 3 and the 5. For the next one, if I have a parentheses with a 3, comma, 5 and a bracket, this time it means that if I rewrote this, I would write 3 is less than x, which is less than or equal to 5. The bracket means that you include the 5, and if I redraw this, I still have an open circle on the 3, but this time I have a closed circle on the 5, but it's still all the numbers in between. So, knowing this next example with a bracket and a 3 and a comma and a 5 and a parentheses, it's going to be almost the same thing as above, isn't it? Except that 3 is going to be included in our solution. So if I rewrote this, it would be 3 is less than or equal to x, a number, which is less than 5. So, let's draw that little one. Can you guess what it is? We're going to have a closed circle on, or closed hole on the 3. We're going to have an open on the 5 and all the numbers in between. And for the last one, since there's 2 brackets, we have to include the 3 and the 5 in our solution. So when I rewrite this, it becomes 3 is less than or equal to x, which is less than or equal to 5. And I bet you can guess, oh, that one a little bit crooked, didn't it? I bet you can guess that we need to have 2 closed holes, both on the 3 and the 5, and all the numbers in between. Okay, that's it for today. Thanks for listening, and we'll catch you next time.